In this video, we're going to be looking at differential equations, and we're going to look specifically at separation of variables. We covered this briefly in one or two of my previous videos, but we're really going to deep dive into it here. Before we really get too far into it, I just want to review really quickly general and particular or specific solutions and kind of what they are, redo some of the definitions to make sure we really understand what they are. So first of all, a solution is the original function. So the solution in this case would be y is equal to f of x. That's your solution, because if you're given a differential equation and you're asked to find the solution, that's what you're looking for, which is the original function. And then the general solution, that would be when you have the solution, but it's the family of solutions, right? So it includes all possible solutions. And then the particular solution, that's where you're finding the exact solution. All right, you're finding the exact solution, so you're able to figure out what that C value is. And in order to do that, you need what's called an initial condition. So the initial condition is necessary to find the particular solution. And usually that's given in the form of something like this. All right. You are given a coordinate. Somehow you're given an x and or a y to find the exact solution. Okay, so let's do an example, finding the particular solution on this one. So for the differential equation, find the particular solution to be determined by the initial condition, and there you go. So your point is right here, -3, 2, and you want to find the the particular solution. The first thing that I would recommend doing, just to avoid confusion, is changing that y prime to dy dx. So if I do that, it's going to be x dy dx minus 3y is equal to 0. Now what we're going to do is we're going to get the variables on the opposite sides. All right, so I'm going to begin by adding that 3y over. So I would have x times dy dx is equal to 3y. Then the other thing that I need to do is to somehow get this over to that side, or vice versa, I guess. That would make a little bit more sense. Not the whole thing, sorry, just the dy. So if I go ahead and divide that, you end up with, and we're going to change it because you're going to end up with x over dx is equal to 3y over dy. Change this, instead we can't divide by dx, so we're going to do 1 over x dx is equal to 1 over 3y dy. Or even further, if we do this one step further, it'd be 1 over 3 times 1 over y times dy, because 1 over 3 is a constant. Now we can go ahead and integrate each side, and I can put the 1/3 out in front since it's a constant. And so when I integrate each side, the integral of 1 over x is the natural log of x, and then you would have 1/3 the natural log of y. Then you'd have that plus c. Then when you take e to the natural log, we're going to go ahead and take this 1/3 and rewrite it as an exponent. So it would be y to the 1/3. That way when we find each side, take each side to the power of e. Right, so that's going to be 1/3. E to the natural log of x is just going to give us x. E to the natural log of y to the 1/3 gives us just y to the 1/3. Oh, and then you would have your plus c. So let's look at this. You would have e to the natural log of y to the 1/3 plus c. But you can rewrite this because e to the natural log of y to the 1/3 is just y to the 1/3. And then that would be times e to the c. Okay, now we have to get y by itself, so we're going to divide out that e to the c. On the left side, you would have 1 over e to the c times x is equal to y to the 1/3. And then we're going to take each side to the power of 3. So you would have 1 over e to the 3c times x to the 3rd is equal to y. Now, the thing to remember, as we've done in the past, this right here, that is just some constant, right? And so what we're going to do to make things easier is we're going to replace that with just c. So it's just c times x to the 3rd is equal to y, instead of writing it as 1 over e to the 3c. Okay, so this right here is our general solution, and they give us a point where we can find the exact solution. So right now we're solving for c. So we're going to plug -3 in here, and then y is 2. And then when we go through and solve there, I'm going to pull this back up here. -3 times -3 times -3, that's -27. So you'd have -27 times c is equal to 2. So c is equal to 2, so -2 over 27. That is our constant value. So again, here is our general solution. So we're going to take that and write in y equals -2 over 27 times x to the 3rd. And that is our particular solution. Let's take a look at an example of separation of variables. So we're finding the general solution of x squared plus 4 times dy dx is equal to xy. So the first thing we need to do is get the x dx on one side and the y dy on one side. All right. So go ahead and try to do that part. Separate the variables, and then from there you can integrate both sides. So go ahead and try to go as far as you can on this one by yourself, and then come back to the video once you've tried it, or if you need a little bit of extra help. Just to get started, I'm going to divide out that x squared plus 4, so you would have dy dx is equal to x times y all over x squared plus 4. Just to get started, and then the next thing I'm going to do is divide out a y. So I'm going to multiply this side by 1 over y and multiply this side by 1 over y. And those y's will cancel here. So you would have x over x squared plus 4 is equal to, and I'm also going to multiply both sides by dx to get rid of it there. So you would have 1, so d1 over y dy is equal to x over x squared plus 4 dx. Now our variables are separated, so we're good to go. So if you haven't tried it, go ahead from this point, pause the video, and integrate both sides And again, you're finding the general solution, so there's no particular solution to find. Integrate both sides. From here, you should be able to do this, but pause the video, try it, and then come back if you need some help. This one, you're going to need to use some u substitution. So you're replacing x squared plus 4 with u. And then when you go through and then find the derivative, you find that dx, you can substitute then dx for du over 2x, which is what I did here. And that's where the x's will cancel, but you still have this 2, which goes out front, so it becomes 1 over 2 or 1/2. So then you have the integral of 1/2. 1/2 the integral of 1 over u, which is then the natural log of u, and then resubstituting u in for x squared plus 4, or x squared plus 4 in for u. Now, this is almost our general solution. We're almost there, but we need to get y by itself. So we're going to go ahead and take e to both sides. So it's going to be e to that, and e, I'm going to go ahead, I got to move this 1/2 up to an exponent. So I can take e to both sides, and you would have e, this becomes y, y equals e to the square root. You can keep it, you can write the square root, but I'm just going to keep it x squared plus 4 to the 1/2 plus c. Remember, we've done this several times already, but you can separate this on the right side. So it becomes e to the natural log of x squared plus 4 to the 1/2 times e to the c, because remember, you can do this because when you multiply like bases, you add the exponents. And so we're just applying the opposite of that rule here. And e to the natural log cancels, so you would have just x squared plus 4, or the square root, let's do the square root of x squared plus 4 times e to the c. And remember, e to the c can be seen as a constant. So your final general solution would be y equals some constant times the square root of x squared plus 4. Okay, that would be your final general solution. Okay, now on this one, we are given an initial condition and asked to find the particular solution. So we're doing the same thing, only going one step further and plugging x and y in at the end to figure out what your c value is. Go ahead and try this one on your own. The first thing you want to do is get the dy and all the y's on one side, the dx and the x on the other side, and then integrate. So pause the video, try it on your own, and see how far you can get. Okay. First thing I'm going to do is I'm going to take this to the other side. So you would have e to the negative x squared. Take it to the, oops, I forgot the dy there. So you'd have xy dx, negative xy dx on that one. And then also on this, I'm going to get rid of that negative exponent by writing the reciprocal. So it's going to be y squared minus 1 times dy over e to the negative x squared. Okay. And then we can get that over. So I'm going to do two things. I'm going to multiply both sides by 1 over. Or sorry, no, it's just e. Now this is a positive, my bad. So that's e to the next x squared. So we're just going to multiply each side by e to the x squared. And then at the same time, I'm going to divide each side by y. Okay, so if you see what cancels, those will cancel, and then also those will cancel. So let's rewrite what we have left. You have y squared minus 1 all over y dy is equal to negative x e to the x squared. dx. Once you're here, you can go ahead and integrate this. Now that our variables are on their respective sides, with the dy is with the y's, dx with the x's, go ahead and try to integrate from here. If you weren't able to get this far, pause the video and try this one on your own. On the left side, what you're going to do, what I'm going to do, I'm going to separate them. So I'm going to look at them like y squared over y and -1 over y. So this over y and that over y. So it simplifies just to y minus 1 over y. Both of those are being multiplied by that dy, which is why I have two separate integrals on the left side. And I can integrate those. On the right side, you're using u substitution. So you're substituting in for x squared, your u. And then when you find the derivative, that's 2x. So dx is equal to du over 2x. And when you do that, that ends up giving you what I have up here. Because you have the 1 over 2, and it's a negative. Don't forget about that negative. E to the u du. So now these are both set up where I can go ahead and integrate. Here you would have the natural log of y. Oh, sorry. No, that's the second one. So the first one is just be y squared over 2, which is the same as 1/2 y squared, minus that's the natural log of y, is equal to -1/2 e to the u, which is u is x squared, and then you have your plus c. Now the next thing that we need to do is to figure out what c is. Now, we could go ahead and go through and solve for y, but at this point, let's just go ahead and plug in our initial condition, because it doesn't matter when you plug it in, right? So when x is 0, y is 1. So it's going to be 1/2 times 1 squared minus the natural log of 1 is equal to -1/2 e to the 0 plus c. And then e to the 0 is just 1. And then when we go through and simplify this, you have 1/2 minus the natural log of 1, which is 0, equals -1/2. E to the 0 is 1. So then we're going to add 1/2 to both sides, and you would get 1 is equal to c. All right, so we know that our c value is 1 in this case, and we go through and we figure out from this point, we try to figure out what our equation is, and we're going to go with this point right here before we plug that in. And it's going to be 1/2 y squared minus the natural log of y is equal to -1/2 e to the x squared plus 1. So that's the exact solution. And looking at that, I do not think that there is a way to get so it's just y. So we are going to stop right there. That is a particular solution, and I really don't believe there's a way to go ahead and solve for y. So we're just going to stop right there. That's as far as that we're able to go with this one. Okay, so here we're going to do one more, and then I'll do another video with all of the application problems. But here it's finding a particular solution curve, very similar to what we've done. Now, if it has a slope of y is equal to x squared, or it has a slope of y over x squared, then that means that that is the differential equation. So we know that this is our differential equation. There we go. So dy dx y over x squared. We're going to do separation of variables. This one's not too bad. Go ahead and try this one on your own. So pause the video, try it on your own, see how you do, and then come back to the video when you're all done to go ahead and make sure that you did everything correctly. Okay, so let's see how you did kind of working through this one. Separating the variables, you get 1 over y dy on one side and 1 over x squared dx on the other side. And then when we integrate, integral of 1 over y is just natural log of y. Integral of 1 over x squared is negative 1 over x. And then you would have that plus c. And then when we take each side to the power of e, so e to the power of each side, e to the natural log of y, that's where we did get just y. And then you can separate those, e to the negative 1 over x times e to the c. And remember that e to the c becomes, we can just rewrite it as some constant. Then we go ahead and plug in our values, our known values. That's our initial condition. So when x is 1, y is 3, then going through and solving, you get 3 times c times, or 3 is equal to c to the e to the negative 1. And that ends up being, because that's the same as 1 over e to the first, and then you multiply each side by e to the first, and that's where I get here. So then that is our c value, because 3e is a value you can plug into your calculator, and that is a numerical value, so that is our c. And when we plug it back in, so again, we're going to come back to here, and we're going to plug 3e in there for c, and then go through there. Now that is, we could stop there, but looking at the e's, they can be simplified a little bit further. When you have the same bases multiplying, you add the exponents, so 1 minus 1 over x, and you can re-simplify this to x minus 1 over x. So you could have stopped back here, that would have been just fine, but going a little bit further to make it simpler would give you y is equal to 3e to the x minus 1 over x power. Okay, so I'm going to stop there for this video. This is all of the finding particular solutions, general solutions for these complicated exponential equations. So there's a lot in this video, so I want to go ahead and stop and then have you work on some of those problems. And in the next video, we will do some of these, or all of these application problems, which are a bit more fun, but require all of the skills that we worked on back here.